Hello everybody, this is Timothy, the Vice President of IPC at UC Irvine, and today I kind of want to showcase to you my audio amplifier circuit. I built this on a breadboard, and I kind of want to showcase it to you because it actually amplifies audio. The components we'll be using today is 3 100 ohm resistors, one 500 ohm resistor, two 470 microfarad capacitors, one 5 volt source, DC source, and finally, we're going to be using an op amp, of course. And the op amp model is a UA7241C. And today, we're going to be amplifying my microphone input. So right now, you are hearing a direct line to my microphone. I'm using my webcam microphone, but as you can see here, I'm going to pass it through the circuit and then amplify it at the end. Alright, but first, let's take a look at the schematic. So here is the schematic that I have made. You are given the audio input, which I represent as a sine wave, and then this capacitor right here removes any DC bias that is going through the audio signal, and then after that it gets fed through an inverting op amp. So as you see, this is an inverting op amp configuration, and the gain is configured to be minus R2 over minus R1, and then once that gain goes through, and then you pass it through another capacitor to remove any DC bias that may come from the amplification. As you can see, we're not using the standard VCC minus VCC configuration. We're actually using a single supply configuration where the plus VCC is connected to a 5 volt and then the minus is connected to ground. So how do we get around this? We use a voltage divider to make the differential between the minus, which is the input source, and 2.5 volts VCC, so that we can amplify that differential, so that the supply rail doesn't get hit when it comes to ground, but instead it gets hit when it goes to either plus 2.5 or minus 2.5 volts, because this is a perfectly split voltage divider, 50-50, and you'll get 2.5 volts at the V+, the non-inverting input of the op amp. And let's go ahead and run a transient simulation. So you can see the input has 250 millivolts, and I employ a high pass filter. Measuring it across ground, we can see that it oscillates around 2.5 volts. And then let's go ahead and measure the output right here. So you can see that it gets amplified right here. We amplify it so that we put it within the regime of 2.5 volts, and then we remove the DC bias by employing a high pass filter so that we can hear it. As you can see, the light blue curve is the output at the end. So let me go ahead and give you what the input is. Let me delete some of the unnecessary curves. So the input is this signal right here, and the output is this light blue one, and you can see you get a gain around 5. Okay, so now that we know that the circuit actually works in this configuration, let's go ahead and try it out. One more thing before we go on. I am using a program called Pure Data to pass my my microphone from my webcam, the microphone from my webcam, to my audio input for the circuit. So let me go ahead and bring it to the camera. So I'm actually passing it through the input of the circuit, and then the output of the circuit will be another microphone, and I plug that into the microphone port of the PC. So let's go ahead and change it up on OBS. Okay, so here is the configuration for OBS. I know it may look a little bit straining, but we can change the microphone input, and we can change that to the high definition audio device. Click OK, and you can still hear the audio input because I'm passing it through in this configuration. Let me go ahead and switch to the camera again. I'm still passing it through here, and then the output's here, and it goes back into the microphone, so you can still hear it. So this is without VCC being turned on. So this is basically just without the op amp being turned on, this is essentially just a high pass filter, because you're going through a capacitor, then a resistor, and then you're going through another capacitor. You're going through another resistor and a capacitor, so it's sort of like I guess a band pass filter if you think about it. But in any case, if we turn on the op amp, then we can hear amplification. So let's go through. Or actually, before we turn it on, let me show you how the circuit works. So the audio input is simulated as a sine wave, remember? And then we bring it to the 470 microfarad capacitor, and that removes any DC bias. And then we have this 100 ohm resistor connected in series with this 500 ohm resistor. Remember, that's the feedback loop to get that gain, minus 500 ohms over 100 ohms, so that's a gain of minus 5. And then we connect it through the op amp, and then we get our output right here to capacitor, and then we bring it to here, which is our audio output. The voltage divider is right here. You see 200, 100 ohm resistors to get voltage divided. VCC goes to this port, this node, and then this other resistor goes from the node to ground, and then this node now has 2.5 volts, and then we feed it into the non-inverting input of the op amp. The inverting, one more thing, the inverting input of the op amp is connected between the node of the 100 ohm and the 500 ohm resistor. So yeah, so this is a circuit. Let's see if we turn on the power supply, this thing. Let's see if we get any audio amplification. So right now you see no audio amplification, but if we turn it on, you see that we do have indeed some amplification, but it's getting kind of clipped. Yeah, this audio amplification is getting kind of clipped because the original gain of the microphone is already way too much. So let's go ahead and turn down the dB. dB is good. Okay. So I'm going to disconnect the supply just to tell you that this is the microphone input before we apply the amplifier, and then once I connect it again, you should hear substantial gain in the amplifier. Yeah, you should hear substantial gain in the amplifier. And yeah, hopefully you see that the circuit works. If you have any questions, you can email ipc.ecurban@gmail.com, or you can message me. Go to my website, timothydoe.me. And yeah, this is my audio circuit. I hope you guys enjoyed it, and let me know if you have any questions. Have a good day.